My name is Rab McClure. I'm a designer, an architect, and the director of the MFA in Design program at VCU Arts Qatar. I'm excited to share the results of this year's MFA on the Go field study project, Virga. Virga is the name of a cloud formation found in hot, arid climates, characterized by trailing streaks of rain that evaporate before reaching the ground. Virga is also a collection of 19 glowing cloud forms lit from within by programmable LED lamps and made from steam-bent wood, 3D printed connectors, and an outer layer of stretched cotton fabric. Virga is a product of the MFA on the Go Field Study Initiative, a distinctive feature of the VCU Arts Qatar graduate program. Each year, students and faculty from our program travel abroad to conduct embedded workshops with expert artists, designers, fabricators, and industry partners, producing tangible artifacts that we exhibit afterward. The project was collaboratively designed ahead of time before traveling for an on-site, 8-day wood-bending workshop with Atelier La Juntana, a teaching and fabrication facility on the north coast of Spain. Virga is the result of a multifaceted collaboration involving more than 30 people. We travel as a group and produce work together under the guidance of experts because we are invested in two schools of theory, situated learning theory and transactive learning theory. The first, situated learning, argues that people learn best when they are embedded within a context tied to the work they are producing. This year's steam bending workshop took place in the Spanish region of Cantabria, known for its stone farmhouses and specimen ash trees. In the Cantabrian tradition, leaves from the ash trees provide shade in the summer and food for livestock during lean winter periods. Stout ash branches are fashioned into farm tools, axe handles, and shovels. Slender ash shoots are woven into baskets. Ash is well suited to steam bending. Starches in its linear fibers break down when steamed, transforming the normally rigid wood into a pliable state. Bent into a mold while hot, the starches reform as the wood cools and dries, taking the shape of the mold. New to most members of our group, we experienced the steam bending process in Spain collectively. An example of transactive learning, we worked collaboratively in close proximity, developing a shared understanding in real time, organically adopting individual roles and responsibilities. The shared learning experience forms bonds within our group. Because students and faculty work and learn side by side without the normal classroom hierarchy, the setting opens lines of communication that continue to serve us when we return to the studio in Doha. Our graduate design program is founded on a constructionist commitment to project-based learning in general, and the Field Study Initiative sets the stage for collaborative learning in particular. In the words of Seymour Papert, "When you learn something in a physical way, it stays with you." Quoting Paulo Freire from his book Pedagogy of the Oppressed, education either functions to facilitate the integration of the younger generation into the logic of the present system and bring about conformity to it, or it becomes the practice of freedom, the means by which men and women deal critically and creatively with reality and discover how to participate in the transformation of their world. Our work empowers students to value their role as shapers of culture and agents of change. Our investment in workshop-based instruction reinforces key themes that define our program. Each year when we travel, we practice research as a creative endeavor. We craft an authentic methodology. We learn by doing. We embrace failure and invite serendipity. We set clear parameters, and we engage in iterative development. To set the stage for our collaborative process, we first examined 4 precedents. The first is Isamu Noguchi's Akari. In the words of the artist, quote, "I was told early on that all a young couple needed in starting life together was a futon and an Akari, a pad and a light. But not just any light, the Akari light, which is a difference because it has a shape, a sense of being. It is light itself. That is, the paper from which Akari is made becomes luminous when the light source inside shines on its surface. However distant the paper is from the source, it all becomes one luminous surface." The washi paper Noguchi used is a material with a deep craft tradition, made from the bark of the mulberry tree. Noguchi's experiments took many forms, including exhibits combining dozens of distinct sculptural objects, arranged to produce atmospheric installations with ethereal celestial properties, at once floating but fixed, soft but rigid, enigmatic but scrutable. The second precedent is George Nelson's bubble lamp. Nelson was a young designer in Los Angeles in the late 1940s, and he badly wanted an imported silk light fixture for his conference room, like the ones he had seen hanging in larger, more established firms. He was unable to afford the price, however, so his story is one of ingenuity. Remembering a newspaper photograph he had seen of ships being mothballed after the war, being sprayed with a self-webbing plastic, he tracked down the company with the spraying equipment. He brought along a spherical metal frame his associate had welded the night before, and he convinced the workers to spray the plastic onto his prototype, which he then hung in his office. By the early 1950s, his team had designed several models and patented the technique, setting up a product line that remains popular today, more than 70 years later. Precedent 3 is the Falcon lamp by Bruno Minari. The Falcon lamp is made from tubular elastic mesh, originally produced by an Italian stocking factory. The lamp's distinctive shape results from carefully placed metal rings of different sizes, pushing outward against the fabric. The project is representative of Minari's design approach, a quest for reduced formal elegance. In the Falcon lamp, the relationship between the two opposing materials determines the form, resulting in a low-cost, easy-to-install product that can be stored and shipped flat. The fourth precedent is Billow and Bloom by American sculptor Kendall Buster. Prior to developing her art practice, Buster studied biology, and her work is informed by a keen interest in organic structures and natural systems. Quoting the artist's website, Billow and Bloom occupies the unique volume of the third-floor lounge of Nordstrom's flagship store at 57th and Broadway in New York City. Billow and Bloom is made by draping semi-transparent scrim fabric over rigid frames and can be observed from multiple viewpoints. Its bell-shaped open forms evoke vessels, jellyfish, botanicals, or even billowing skirts. The clusters of related but individually distinct forms, translucent and lightly floating, recall cumulus clouds, shifting, drifting apart, and reconfiguring into new formations as one spirals upward through the space, viewing up, down, across, and through gaps between the individual forms. In this shot, looking upward through a break in the clouds, the photographer captures the artist in a contemplative moment. The installation lends the space a dreamy, atmospheric quality, which is a point of inspiration for Virga. We also drew inspiration from literature. This line is from Antoine de Saint-Exupéry's novel, Night Flight. The plane soared through the clouds, the mist swirling around us like a cloak. It was as though he had entered a new world, a world of softness and light. Designers were free to develop any curved geometry they liked, provided it fit inside the rectangular boundaries of a suitcase, with no bends tighter than a radius of 8 centimeters. Designers chose the number of sides their cloud form would have, selecting a number between 3 and 6 sides. Because students begin our program with diverse backgrounds and wide-ranging skills, some had never worked with 3D modeling software. To guide everyone through the pre-travel design process, I provided templates and step-by-step tutorials. Each person began by drawing a two-dimensional curve. The rectangular border in this illustration is the 45 by 65 centimeter boundary of a standard large suitcase. The curve was offset 5 millimeters in each direction and capped at the ends, which were aligned vertically. We extruded the closed curves into three-dimensional battens, 10 by 20 millimeters, and copied them around a central axis, choosing to make between 3 and 6 total. Next, we generated the geometry of the cotton fabric diffuser by forming surfaces along the edges of the curved battens. The ends of the curved wood battens attach to a set of circular rings at each end, and, offset from the circular rings, a pair of polygonal braces provide a straight edge for attaching the fabric surface. In the digital model, we added flaps to the fabric surface, designed to wrap the top and inside edges of each brace. These flaps attach with Velcro, adding adjustable tension to the cotton fabric. We used the software to unroll the three-dimensional surfaces and flaps, and then added seam allowances, notches, and notch tags to generate annotated patterns for the tailors. Following a check and review process, the finished digital models were used to produce 3D printed rings and braces, which were tapped and threaded so that we could attach the bent wood battens with screws. Along with the 3D printed rings and braces, unique to each project, we also modeled and 3D printed jigs for each project to ensure that the holes drilled into the battens would align with the rings and braces during assembly. At that point, we were ready to travel. On site in Spain, we cut, steamed, and glued the battens, sanded them, and drilled the holes using the 3D printed jigs, and then we tested the assembly. The workshop concluded with an exhibition and celebration at Atelier La Juntana. A set of clear parameters established at the outset created a project grammar, ensuring a consistent form language for the whole collection. The parameters offered flexibility to each designer, encouraging a variety of solutions, but also ensured coherence and harmony throughout the resulting family of forms. When we arrived to begin the workshop in Spain, molds were waiting for us, digitally fabricated ahead of time, using the geometry of each designer's curve. We trimmed the ash strips to length, marked them to identify each project, soaked them overnight, and placed them in the steam chamber for several hours. When they were ready, we pulled the flexible strips of wood from the steam chamber and inserted them into the molds, pinning them to the curve with wood shims. The wood was then allowed to cool and dry overnight in the molds. The next day, we removed the bent wood strips from the molds and glued them together. We placed the laminated strips back into the mold and used the shims to pin them to the curve until the glue dried. Following this step, the wood held the exact shape of the mold. On the last day of the workshop, we had a celebration and staged an exhibition, hanging the lamps in the fabrication shop of Atelier La Juntana. We exhibited some projects with just the frame, some with the fabric diffusers added, and some lit internally with lamps. A short video, next, documents the steps of our steam bending workshop in Spain. Here we are back in the Cloud Factory. After returning to Qatar, I used the break between semesters to reassemble each lamp, attaching the cotton diffusers and requesting alterations from the tailors as needed. At the same time, I worked with our partners from XLab to refine and develop our strategy for suspending, powering, and installing the lamps. Our goal was to compose an arrangement in the gallery that would recall Saint-Exupéry's world of softness and light. In our solution, the 19 lamps are grouped in quadrants. The position of each group allows it to move freely past the others. Servo motors mounted above silently lift or drop each group in a carefully choreographed sequence, designed to recall the slow movement of floating, drifting clouds. In this illustration, 3 groups rise at one rate, barely discernible, while one group falls more quickly. As the highest group reaches the top, it begins to fall, and a different set of 3 groups slowly rise. A looping sequence, the clouds are in constant motion, rearranging and recomposing over the course of the day. In addition to the exhibition mode just described, we also designed an access mode to bring each group down one at a time for cleaning. The kinetic function, as a result, is designed to be both poetic and practical. Unfortunately, In the run-up to the exhibition opening, our technical partners were unable to resolve problems with the power supply, servo motors, and cable spooling. Collaboration, like the weather, can be unpredictable. We made the decision to suspend the lamps at fixed heights and to rely on the programmable light sequence to add a kinetic dimension to the installation. The resulting composition relies on the variety of cloud forms produced by the 19 individual designers for its atmospheric effect. The grammar of the project brief produced a family of related forms that share common traits but stand out as distinct individual voices within the overall composition. Several designers chose to orient their curves horizontally within the long dimension of the suitcase, producing overall cloud forms as large as 130 centimeters. The narrowest solution is just over 20 centimeters. As a result, the narrowest lamp is also the brightest because its stretched cotton diffuser is closest to the light source. The largest cloud forms not only contain the shortest light sources, but also place the cotton fabric surface furthest from the source, making them noticeably dimmer. The process of installation began in January. First, workers installed trusses 8 meters above the gallery floor, spanning wall to wall, and then they hoisted 3 painted panels into position, each of which had been assembled first on the ground. Programmable, networked electronics mounted to the top sides of these panels control the light. Here are the workers lifting the last lamp into place. And this is the scene as we turned the lights on for the first time, as the last worker came down off the scaffold. This is the night of the exhibition opening, when we opened a set of large ceremonial doors that allowed guests to spill out onto an adjacent terrace. A mild breeze that evening introduced soft, subtle movement. To conclude, I'll share 3 video clips of the finished installation, accompanied by quotes from Gaston Bachelard's book, The Poetics of Reverie. To see clouds in the sky is to experience contemplation. The reverie of clouds leads to an awakening of the soul, to a realization of the essential values of life. The cloud is a symbol of the unconscious. When we look at a cloud, we are reminded of the power of the imagination and of the possibility of exploring the unknown and the mysterious. The cloud is a symbolic form that invites the imagination to play. It is a form that suggests the mystery and the poetry of life. When we see a cloud, we see something that is both there and not there, both material and immaterial, both real and unreal. The cloud is a symbol of transformation. It is a form that suggests the ever-changing nature of existence. When we see a cloud, we see something that is constantly evolving, constantly shifting, constantly becoming something new. The cloud is a symbol of the infinite. It is a form that suggests the vastness of the universe and the limitless possibilities of the human spirit. When we look at a cloud, we are reminded that there is always more to explore, more to discover, more to dream.